So first we can start with a math module. If you want to work with a math module, maybe like I do math.ipynb. It's an IPython notebook. If I have like a math thing, basically, whenever you work with a IPython notebook, first we create the environment and you work on it. If you see like first the import math module, math is also same like an ordinary thing. So there are some modules which will come by default when you install Python. One such is math module. And if you see the DAR of it, you will notice a lot of attributes. In fact, I created this entire process of this IPython notebook. So so to start with, first we import the module. Then like in the DAR, you can see a list of attributes. So there were a lot of things in maths what we can do. And in every version of Python, they are adding new functionalities. So over a period of time, whenever you need something, you can just go. If I say help, so dir will give the attributes where help will give the entire documentation. Then every module will have two types of things. One were the constants, which are the variables, and two functions. So math.py is a constant. Math.e is an exponential. Math.infinity, not a number, or tau. These are all mathematical constants. At the same time, we have functions also. And they created functions. This math module was created in Python 2.6, 2.7 at the time itself. At that time, certain features are not available in Python. Say the simple example is power operations. Initially, the power operator didn't come, or like some other features. So in the evolution process, they created a math module for doing all the things. And over a period of time, some of the things became a modules, attributes, operators like that. So now I will make a comparison also sometimes with our traditional usages. First, if you see the math.ceil, what it does. For any room, think like that, ceil will be in the top, right? So floor will be in the down. So just imagine like that. This ceil, what it does, if you give 9.7 or 9.5 or 9.1 or like 9.0 or 0 dot so and so, or like 9 or minus 9.7. Every time it will try to go towards the next highest value. So now in the process, what it does, if you go for 9.7 or 9.5 or even 9.1, after 9, what is the next integer? 10. So that's why even if you have 9.1 also, it became 10 only. But what if I have 9 point, these many zeros and 1? By the time it will take itself, it will round off. So that's why it will be a 9. So that's why it will come 9. But if you ask the ceil for a 9, 9 is already integer, so you won't get it. Similarly, 9.1 minus if you do. So in negatives, reverse happens, right? Minus 9 is so greater than like minus 10. So that's the reason. So you'll get minus 9. In the same fashion, floor. Floor means what? Lower value. What is the lowest integer for 9.7? Before 9.7, 9 is there. So for 9.5 also 9 is there. 9.1 also 9 is there. 9 point these many also you do 9 is there. So in all the cases it is 9. But for minus 9.1, which is the smallest? So in negatives reverse happens, right? So whichever is smallest, minus 10 is less. So that's why you get minus 10. In the same fashion, there is something like truncate. Truncate will not do like towards something. It will just ignore the floating point value. Means after dot, what are the values? It will just ignore and give you the values. So that's why trunc, it will give every time integers. So it is not like positive or next value or so and so, just ignores the negative. And in fact, our built-in int function, which we are using now, it is also does the same job. No matter what you give, 9.1 or 9.5, it will just ignore the value after the decimal it will give it. That is the truncating. Whereas round is different. Truncate means it will just ignore the remaining part. Whereas round means if after any integer the decimal values are like between 0.0 and 0.5 till 0.5, it will go to the previous integer. So after that it will go to the next integer. And this round function is only present in Python 3. In Python 2 it's not there. If you see the round function, the first two are like 10 because like that. So less than or equal to 0.5. So you get this one. But beyond that, if you go, so did you see? For the remaining values, it would be 9. Means if you are beyond from 5 onwards, beyond, it will be so the next value. In the same fashion, if you do round. So round I applied for different things also. Hope you remember. When you do it like the math problems I showed you, like shopping mall problems. And if there is a round of math.py, see round if you do, and if you don't pass any argument. So or if you pass an argument like it's 0 also, but it will be different. If you don't pass any argument, it will result in an integer. If you pass an argument, even if 0 also, then it will become a float. Observe carefully. So that's the reason for round, if you pass any value, means post decimal, you want those many number of digits. At this moment, 5 has that kind of value. But if you give a value of 10 and ask to round, there is nothing, right? So only when the value is there, we can see that. In the same fashion, you can see, so if I give round of a given number I give. So though you gave like here like 9 digits precision, but still it can do max this much only. So that's what I'm trying to say. Though you give the round off, if we don't have those many number of digits, it makes of no use. And similarly, there were like some custom functions. Math.next after means like if you are given a number, so our next after x towards y means after 5, I want the numbers towards 5 means 2 to 5. So between that you want some value. So again, if I ask like 2 to next value, if I say, so some floating point value it will give. So similarly, if I say from 2 towards minus 5, if I ask, did you see both times I got the same answer? Means next after every time when you go and iterate, it will give the first value like that. And next after if you give from 2 towards minus 1 means in the reverse direction. So similarly we have power operation. As I told you, power built-in function also we can use, or math.power also we can use. So means sir, there are two functionalities for the same thing? No. So there is a slight difference. When you do your ordinary power operations, whenever the result is say 2 to the power of 4 means what? 16 or 64, I guess 64, right? 16. Okay. And if you do like math.power, it will give like a floating point result. And observe from now onwards, so math.operations mostly give a floating point result. So why they created means in Python 2 there used to be some scenario due to that like division is not correctly done. So to avoid that there is some issues. I don't want to tell all of that. So to maintain that they made everything as floats in thing. That's the reason. See here, in an ordinary computation, if one of them is float, then you get a float. But in math.power, whether you need or not, every time you get float. Similarly, in an ordinary math operations, we cannot do this kind of power of 3 values. You know, in built-in function power, I can pass 3 arguments also, but that we cannot do with a math.power because math.power takes 2 only and it does power operation only. It will not do the modulo at the last. In the same fashion, there are certain operators which are repeated, right? the remainder operator, which we know for the remainder. So similarly for the remainder operator. And same like remainder operator, we have f absolute. F absolute means what? If I say 10 by 2, if I divide 10 by 2 means it is divided by 5, right? Then what will be the result? 2 5s are 10, remainder is 0. As remainder is 0, you got 0 0.0, comma 0. But if I say like 10 by 3, so 3 3s are 9, 1 is remainder. So that's the reason here in this case it is 1.0. Means even remainder also is doing the same thing and f mod is also doing the same thing. Then what could be the difference? So maybe that I will leave for you for assignment. And in the same fashion, there is one more thing like f absolute. Hope you remember I told that absolute means if you give any number and if you want to get the positive value, whether I give negative value or positive value, I need to get the positive value. In that case, I go with absolute, right? AVS. In the same, if you go for f absolute, so you will get a floating point. So positive floating point value every time. So even in this case here, 9.6. So ordinary ABS will give 9.6. But F absolute will give 9.6. And similarly, sometimes if you want to get the sign of one value, means I want minus 9, means this 9 is there, right? First value. So I want the first value with the sign of the next value. Now you see here, though I have minus 9, I got 9 because, so it will take the value from the first one and the sign from the next one, second one. And this is called as copy sign. Means like it is something like I created a indirect execution in the backend. What are the number you give, it will take the absolute of it and it will give the sign of it. So the first value is like 9, you get the 9, and the second value is minus 2, so you get the minus. Means it doesn't matter what is the value in the second position. You can have minus 2 or minus 2 crores, it doesn't matter. And here also same thing, it will take the 9 and the sign is like minus, so you get like a minus 9. And similarly the first value is 9, second value is plus, so that's why you got like plus 9. In the same fashion, if I do math.factorial, so we have did the factorial with directly or like using reduce, different ways. The same thing can be achieved using factorial of this thing. So factorial means it will calculate the numbers. In the same fashion, hope you remember the sum operation. Same like sum, there is f sum. Means the result will be float, that's it. So whether you deserve or not, it will give float. Next, after this, there is something called as GCD. Greatest common divisor. Means if you are given two numbers, so the two numbers we need to do like get the divisors and common divisors we need to get. So 12 means what? How we can write like 4 into 3. 4 means like 1 into 4. So 4 is like common. You got it. Similarly, I can get the GCD of 3 values or 4 values like this. And in the same lines, we can get LCM. LCM means least common multiple. So 12 can be represented as 4 into 3 into 1. So 4 can be like this. So what is the least multiplication? So 12. And similarly, if I go for LCM, and in the same fashion, so LCM also can be passed to different number of arguments. And next is square root. So we don't have a built-in function for square root. Math is the only option we have. So every time if you have observed, math.square root will give a floating point result. Same like square root, there is something called as cube root, which was recently introduced some couple of versions back. You can calculate the cube root. It is saying that, hey, I don't have this version of cube root. Now, why it is not having? because I am doing Python 3.10. Now, whenever something happens like this, you can check, hey, in Python, so cube root, math, so cube root. I can check like, so math cube root. If you see, you will understand that, okay, we have the cube root. So don't go for the third parties. You can directly go to the main thing. So it was created when, so we can see like 3.11. Now we are in 3.10. Then how can we get? So we can increase this version by just making the kernel. Means like, so what are the default version you're getting is this one. But you can create your own kernel and add that. So that will be a point for next discussions. So let's leave that. And then like cube root, it doesn't work, right? Ignore. And we can say like modf. Modf means if you are given any number, divide that to real value and like floating point part. Means 1.5 can be divided to an integer and the remaining value. Integer is 1 and the remaining part is 0.5. So that's why you will see. So 0.5, the extra, and the integer is 1. In the same fashion, if I give like this, the remaining part is minus 0. So and so, and the integer part is minus 12. Means whenever you have negative also, it will take. But if I say 32, it is a rounded off number, right? It integer. Then how I will get? The remaining is nothing. So 0 you will get, followed by 32. In the same fashion, if I go for math dot square root, so exponential. If I do math dot exponential of 10, so or math dot e to the power of 10, both will do the same job. So like exponent, there are exponent m, exponent, many things are there. Recently new things are also coming. You can check all of them. Even for the logarithmic also. So logarithms of base 10, this is a base e log, base 10 log, so base 1p log, base 2 log, like the different logarithms also there, right? And apart from that, it supports trigonometric operations. Trigonometry means you will have degrees and radians. So if you are given a degrees, how to convert to radians like this? Or like you can do it directly, your own calculation. So every time I'm using a built-in function and also I'm doing my calculation. Just to tell you, the same calculation will be done in both ways. So if you are given a degrees, if you want to calculate the radians, you can use math.radians or you can do this entire formula. Similarly, if you are given a radians to calculate for degrees, you do like this. And apart from that, if you have, we can calculate the sine of something, 90 degrees, sine of 90 radians. Generally, we know like sine 90 is 1, right? Sine 90 means sine 90 degrees radians. So like that. And similarly, cosine, so tan 90. So tan 90 radians means different. So tan 90 degrees is different. So a cosine means so a cos, a tangential means like that hyperbolic values you have. Hyperbolic cos, a cosine h, cos h, tan h, cot h, all of them you can do. And apart from that, you have Euclidean distance. Means if you are given one point, from that point, how much distance it is to the same point. That is called as a hypotenuse, means Euclidean distance. So the name number square and the second point square. So that would be like that. So hypotenuse means from 0 onwards, how much distance they are to calculate. Similarly, if you want to check some data which is coming, whether it is is it a number or not, I can check that. And if it is a number, is it finite or not, or whether it is infinite. So then like I was into this thing. So where like, so the gamma functions, so gamma is like logarithmic gamma. These are like mathematical functionalities. So whatever I told were like to some extent, but still a new functionalities are coming. So apart from this math module, You now understood how to work with a simple module and how things are working. So the next thing that we will see is about the Sys module, which is the most important thing among it is Sys module. What if this Sys module does? How it can help us? Let me start to understand it. So Sys module, so IPYNB, sorry. Okay. So I pulled the content already. I'm clearing all the things and I want to run freshly. So if I run, if you want to run all the cells or like a particular cell, you can choose. First, I take the environment and I'm asking, hey, Sys module, if you go for the attributes, did you see? It is having a hell lot of things. You know, Python is a platform independent language. Whether you work in Windows or Linux or Mac, the same thing works, right? But who facilitated all these things? Means two modules comes to the primary. One is the Sys module and the OS module. So Sys module is so interesting that you will learn a lot of things. Whether you remember or not, most of the things that we have worked till now, some way or the other I use Sys module, right? Now, what is this called as base exception, base execution prefix, base prefix, and prefix. Now let me execute these four. Did you observe that all these four are same? No difference you found, right? So that's what. Now till now we are working with the ordinary environment and we don't have like a separate thing. Now let me do a slight difference. If you want till now what you are doing, you are working on the environments. So if I go with like creating a new environment means if I say Python, it will say where the Python is stored. Okay, Python 3.10 it is saying. Previously also some functionalities you couldn't execute because it is a older version of Python. And if you want to know, so where this Python is stored, there is a Linux command called as which. So if you ask which, it will tell where it is located. In this container, so in the code space, in the Python, in this directory, bin Python is there. In the same fashion, now if you want to create your own environment, there are multiple ways of creating our own environment. So first is like creating using virtual environment. What is this concept of virtual environment, sir? Means you are in a system. In a system, if you are working on three projects, project 1 if you are working on 3.9, another project you are working, maybe you are supporting that, for that you are working on 3.11, another project you are working on, say same 3.9 itself, but the modules versions may be different. Now when you install all of them or upgrade the Python, then what happens? You cannot support the Python 3.9, right? Some of the features will fail. At the same time, the other way. To avoid this kind of problem, we can like isolate each one separately. Now the concept of containers came to picture, but these virtual environments were there before also. Then what are the different ways of creating? So traditionally, if you want to create a virtual environment, so we need to use Python -m. So pip install. For the first time, we need to install a module, virtual env. If I do like a pip install virtual env, it will first install this module. This is the module. If you want to install any module, this is how you install a module. So the moment you install, did you see what is saying? Hey, you have installed, but did you see your Python pip version is need to be upgraded? Means if you want to upgrade anything, you can do like this. Means if you want to install, this is how you install a module. Installing a module. Whatever you have module, this is your module name. And if you want to update, or like upgrade, whatever you call upgrade, then this is how you do. Means even pip also for upgrading, you need to follow the same path. So it is saying what? I have installed, everything is fine. So that's it. Some warning it is saying, ignore it. So now I have this module installed. Then what I can do with this module? First, I need to create a virtual environment. First, I will say the list of files. In the current directory, I have any files more? These were the only files that you are seeing. Now I do the virtual env. Sometimes if you do immediately in Windows, it can be an issue. Don't worry. In that case, you can say python-m. Whenever you say like, if it says virtual environment is not installed like that. So we need to create a virtual environment. Generally, virtual environment is not a main code. So that's why you start with a dot. Maybe like I call it as a venv. That's it. Now we see a new folder is getting created called as venv. And at the same time, this VS Code also noticed this. Hey, do you want to install it? Yes. You can see now what I am doing. I created a virtual environment. You can see a new folder was created. The virtual environment structure will be same. But the only difference is in Windows, instead of a bin, it will called as a scripts folder. In Linux or any other POSIX, it will be a bin. That's the only difference. Means it will create a separate Python installation. A Python 3.10 or whichever version you have, it will create. So as you are working on Python 3.10, it created also virtual environment in the same version. Maybe I will tell you the different options afterwards. But first you created a virtual environment. So now after creating a virtual environment, we need to activate it. How do you activate a virtual environment? Means we need to navigate to this directory. Under this we have a bin, and under this we have activate. If I say activate, then it will execute. It is saying that what? Permission denied. So means you should have a permission to do it. So what we can do, we can give the permissions. If you want to change the permissions, chmod +x means you are changing the permissions. Executable permissions you are giving. Now if you run it, so it is saying you must source this script. So source bin activate. Yeah, okay. I can do the same way. Means first we created the virtual environment. Create virtual environment. So for that, what I did, so python-m virtual env dot venv. This is the name of my virtual environment. It doesn't mean that it should start with a dot. It's a best practice. What are all these not the main code, we write with a dot. And then after creating the virtual environment, we need to activate it. Activating the virtual environment. How do you activate it? So in Linux, you need to do the source. But in Windows, just you go with like, if it is a Windows, the same thing will be like, you just need to run. No sourcing, nothing is needed in Windows. In Windows, what you go? Under that, there will be a script folder and activate. Whereas here, first we need to, make it like a executable, chmod, so +x, and you do. Then you source it. These are two steps. In Windows, this is one step. Now, did you notice that a new thing came here before my thing? So that is to tell me that I know I'm now in a virtual environment. Earlier, you remember when I asked like which Python, it gave a different path. But now when I'm asking which Python, did you see what it is saying? Under the Python engineering, so this folder, under that venv, under that we have a bin, and under the bin, did you see there is a Python? So what is this Python? This is the actual software which is running all this code. Means, so in the system there can be one version, but you are working on this version of Python. Super, right? Now, as you have activated, now we want to work with that environment. So if I go, I can give, so the select the kernel. If I say select Python environments, I can tell, hey, so there is a .env, do you want to take it? Yes, now I told take that as an environment. The moment I took it, so again I can run the same command. This command, if I execute, so I can clear all the outputs. Or like if you see here, I will run this module again. See, for the first time it is doing the IPY kernel. This is something which is needed for the kernel to run, means for the Jupyter notebook to run. So, and like it ran it. And if I ask DAR, nothing different. But observe this thing. Earlier it was like this, but the moment I used it, did you see the difference? So there are two things, base prefix and base executable prefix, and prefix and executable prefix. Observe carefully. In every system, the moment every system wise you can have one Python installation. In that you can have n number of projects. For each project you have a separate virtual environment. So the project wise environment path it will give, whereas the base environment path it will give. Hope now it is clear for both of you, everyone. So this is all about this module. We activated the virtual environment and we are working in it. And if you see sys.byte order, so this byte order means whether you want to go with a most significant bit or least significant bit. It's very simple. So it's nothing to do with us. There are two things like big endian and small little endian. So, most of the people go with this one only. So it is like little endian. Little endian means whichever is smaller, that should be at the right side. Mostly we follow the same structure, right? But if it is a big endian, so I think like IBM missions came with this big endian. So now almost everything is little endian. Means nothing to do with us. So the structure, the lower byte will be in the left side, right side. So higher byte will in the left side. That is a big endian. That's the only difference. And you know about the bin and others. If you see, every time, so we go in an order like this only, right? Yeah, leave it. Next, if you see sys.copyright, whenever you open any interactive mode, you get a copyright information. All that is because of this. And similarly, there is something called as debug malloc status. Debug malloc status means, so it will give the memory, how many pools were there, how many blocks were created, so Python tuple objects, how many are created, so entire information about the memory. So whenever you are working with the C profiling, I will help you understand this. Then there is like a don't write byte code. At this moment you will not understand, but I will tell you that whenever you can even download a module. So whenever you're doing user defined modules, I will tell this. So whether there is something called as PYC files, called as bytecode files, whether you want or not to create them, I will tell you. And next thing is about the default encoding. If someone asks what is the difference between Python 2 and 3, the first and foremost difference is the encoding. The default encoding in Python 2 is ASCII. Means Python 2 is designed for the English keyboard only, mainly. So that's the reason non-English characters, you will have a hell lot of problems. But to avoid all those problems in Python 3, they made default encoding as UTF-8, means Unicode, means all languages you can work. English, so Telugu, Tamil, so whatnot. So, and like the file encoding and everything it is giving. So the default is UTF-8. Next one is about the switch interval. What is this switch interval? Switch intervals tells about, memory when it is switching, means like, let's say, uh, whenever you have like a concurrent calls, like in multi-threading. So when you want to go from one thread to another, so how fast it will switch, that duration it will tell. It depends on the machine. the machine has like the CPU clock size. Based upon that only this switch will come. And next there is something called as reference count. This is the most important point you need to be aware. So till now, how the memory management happens in the backend is, if someone asks, it is get reference count. So means like for any object, till now what you know, if I create an integer or a float or something, how they are storing in the backend. If I give like 1, 2, 3, 4, what it does, you assign to a variable. Then first it will create this 1, 2, 3, 4 somewhere and assign that to this variable. So again, if you assign something else, so means like for the same number, if I say number 1 is equal to 3, 4, 5, if I say, now another block will be created called as 3, 4, 5 and assigned to the same number. Then what will happen to this 1, 2, 3, 4? As there is no variable referring to it, it will be vanished. Means it won't be automatically vanished. So if no one is referring, then in the next iteration, so garbage collector will be removing. There is something called as garbage collector which will help. Else what happens if nothing is removed? Just imagine like you are in an almara. In an almara, so you will have a lot of space. Just imagine, and you can place a lot of things. But if the old things were not removed, there won't be space for a new things to place in the almara, right? So in the same fashion, if you are working everything, when you create a variable, if everything is stored in memory and the memory is not getting cleaned up, you will not have a free space to have one more so operation, right? Whatever operations I am doing, so everything needs some memory. How it will be managed? So in languages like C language and C++, you do all the things as a developer. But in this latest language like Python, Java, and Go language, they have a automatic memory management where there will be a garbage collector which will take for unreferenced objects and delete it. So that is the main point. If you see, initially I am doing number 1 is equal to so and so. Observe carefully. So initially I told like number 1 is something, and after that I am deleting this number. So basically it should reduce this delete count. So if I do like a delete of number 1, so it is saying that after this I don't have this number. How you are asking? It is saying because you deleted above it. If I ask the count, did you see what it is saying? Every time it is saying 3 only, right? Yes. What is that 3? Why it is happening? Because this get reference count, whenever you are asking, so it will check in the memory how many variables are referring to this 1, 2, 3, 4. It will check. So till now, no, you are the only person, right? Who else would have referred? So that I will tell you. So I am doing a for loop of so and so. So and for each of the numbers I am doing. Observe carefully. Means for what I did is like for every 7, print a new line like that. Observe carefully for each of the number, what is the reference I am saving. 0 is referred by these many things. Means 7 has these many references. Means like, for every number, how many references are there that it is showing. Maybe like if you are confused, I can give like this. Observe carefully. Okay, I think I have a new line like this. That's the reason. Yeah. If you see now, you will understand clearly. 0 is having these many references. But sir, sir? Where is the, we didn't create those many variables. Means sometimes in the backend. So in the backend also Python code is only there. So if you see this virtual environment, you will understand. In this virtual environment also we have Python scripts only. So this everything setup tools is having your Python scripts. In fact, all these Python scripts, when they are executing the backend, they use some variables, some values. So we can see that some are referring. 1, someone is referring. 2, someone is referring. So 5, these many references. 30, so means like that. If I go to this, you will understand. For every number, you have these many references. But if you go beyond the numbers, so did you see the references are reducing? If I go for 150, 120, so 200, So the references are reducing. But after 256, did you see things changed everything? That's why I told there is something called as dual memory management strategy. From -5 to 256. So how many references are there? It will just store the reference, but it will not create a new object whenever you're assigning. But subsequently, did you see? For everything, whenever you ask, it will say 3. So whenever it is saying something is 3, means like it has no other access. Just imagine like, it is not that 3 people are, sorry, 3 variables are referring it. See, whenever you are asking also, you are referring, right, to that number. So like that, reference will come. So just imagine like if something is giving get reference count of 3, means like when you are referring also, it will do in the backend. So that's the numbers. If any number is having more than that, it means that it is having more connections. If the reference count becomes 0, finally, it will be garbage collected. So similarly, so the reference count, it doesn't mean only for the numbers. Any variable, any value you create. Say I have strings. I'm saying this random blah blah. I wrote. So for this also it is saying 5 times it was referred. Minimum 3 times will come. Ignore the anything beyond. Below that means like, so for everything, even if you don't have also, for the first time if you are using also, minimum it will give 3. So beyond that I got 2 means like sometimes it was stored here. So that's the reason. So for everything it will have references. And also we cannot give the exact justification why it got these many references in the backend. But what we can remember as an individual is that if this reference count becomes 0, then automatically garbage collector will remove. So you need not be aware. So but it is an automatic process. Just be aware this much. Next. So that's why sys module, you will learn a lot of things, internals about Python. Next, there is get size of. Till now, we are using get size of for multiple things, I told. So for ordinary data types, get size of will be same as like the others. But if you go for like collections, then right, it will take much more size. I showed already. And similarly, there is like get Windows version. So this get Windows version, what it is saying? Hey, I don't have this attribute. Because I'm working in Linux, I cannot get it. Means for the first time you are seeing some attributes which are not working in other operating system. Like that you will see something else afterwards. This works only in Windows. So there are some things which work only in Linux like that. And next is the hash info. Means this is nothing for us, but for the people who are developing Python, the version of this hashing. I told whenever you create any immutable object, means like a set or a dictionary keys, they will first check whether it is hashable or not. I told for the immutables only we can do a hashes. For mutables we cannot give hash. That hash function concept and its version, how they are creating the hash, all of them it is giving. So next, if you see the hexadecimal version, so similarly hexadecimal also how it is created, what is its version, so and all the information. And similarly sys dot implementation. This is where you will understand about Python. So Python is also called a C Python. Why it is called a C Python? Simple, because the Python on its cannot run on the machine. Remember it very clearly. So Python is of 3 types. One is like C Python, and like Jython, and like next one is Ironthon. These are like 3 versions differences. So and there is like so PyPy also, means these were like different implementations of Python. So why they came to picture is that by default Python cannot convert the code to the machine. It needs someone to do that. So for that it need a compiled based language, because Python don't have a compiler on its own. So the most common thing is C language. Means from Python it will convert to C language. C language has a compiler, right? It will convert to the machine level language, then to the assembly level language and machine level language. So whenever you convert, that's why it is a bit slow compared to C language, Java and others, because we have a double conversion, right?
So that's why it is called as C Python, because the base implementation is C. Similarly, from Python, we can convert to Java, and that is called as the Jython. So from Python, we can convert to .NET, that is called as Ironthon. Similarly, there is another version called as PyPy, that is also faster versions. So like the different things are there. Similarly, if you have like int information, so how the int function is created. So similarly, the interactive hooks. The moment you go into the interactive hook, so what to be created? So means you can try this option. So means like you can register one of the function to it. So how we did the debug hooks, so exception hooks I did, right? Like that you can do. You try writing python -i any script.py. You create a script.py file and you do a -i. First you register a interactive function to it. Then whenever you are doing like this, so the script will be run completely. And when going to the interactive mode, it is asking you, it will call it. In the same fashion, we have like get max, get minimum values. It doesn't mean that more than this size it cannot accommodate. It can accommodate. It is just like an absolute. Earlier it has validity, now it's no more. But so max Unicode is still valid. Means you cannot create a so Unicode after this. Unicode so have a numbers, right? ASCII numbers. So I told like Unicode also has a numbers. If you go for any number, so the exact number I gave, it is creating a Unicode. But beyond that, if you ask, it will throw an error that I don't have. Like that, we have built-in module names. Till now, we are working on Sys module, math module like that. So like that, there were hell lot of modules like this. We already worked on like functools. I showed some examples of collections also. But still, I'll work on other modules also for you. So if you just want to see the modules, so I have a list of these modules. So these are all modules, OS modules, and all these things I will do. So just now we've seen virtual environment. Means each module has a different purposes. So we can see that.